Okay, we're going to start talking about section 4.4, which is dealing with logarithms. I usually write it log base a of x equals y if and only if a to the y equals x. I did not misspell if. It's an if and only if. It's called a biconditional. An if is a one-way conditional. If this, then this. But an if and only if is called a biconditional. It works both ways. If one is true, then the other is true, and vice versa. If the second one's true, then the first one's true. Now, the first way is written logarithmically. Logarithmically. The second one is written exponentially. So sometimes you're going to have to convert from logarithmic form to exponential form and exponential form to logarithmic form. Here's just a basic example. How about log base 2 of 3 equals y? That's written logarithmically, would you agree? Can you write it now exponentially? I usually say the base remains the base. So do you agree A is the base here? Let me do it in highlighter. A is the base here, and A is the base here. So the base is 2 raised to the y equals 3. So now I've taken it from logarithmically and written it exponentially. Now let's do one that might actually have a value that we can deal with. Log base 2 of 8. You need to at some point think of this as the base to what power is 8. 2 to what power is 8. So this value would in fact be 3. But let's take a look. This is written logarithmically. Now I want to write it exponentially. The base A is 2 raised to the y equals the x, which in this case the x is 8. 8 could be written as 2 to the third. If you can just look at these, the bases are equal, the expressions are equal, therefore the exponents have to be equal. So yes, the value of this is 3. Here's what they give us on example 1. There's 4 parts. They are all written logarithmically. Log base a of x equals y if and only if a to the y equals x. So I want to write 2 to the third equals the x, which in this case the x is 8. Now let's do the same with the next one. The base is 4 raised to this 0 equals 1. How about part C? Could I write the base 12 to the answer 1 equals the argument? And this one would be the base raised to the negative 1 equals 4 in this case. So what you're doing is you're taking them from a logarithmic form and you're writing them in exponential form. Okay, we want to evaluate all of these. I know that it's log base a of x equals y if and only if a to the y equals x. So the a is a 4 raised to some y power equals 64. 64 could be called 4 to the third. So the bases are equal, the exponents have to be equal. So the answer to this value, this logarithm, is 3. In other words, the easy way to think of it is 4 to what power is 64? Here I'm going to say 5 to what power is 1/5, and the answer will be -1. But let's go ahead and write this out. 5 raised to the y is equal to 0.2. 0.2 is 2/10 or 1/5. Writing it with the same base shows me that the value is going to be -1. Let's do the same with the next one. Ideally, I would say 1/5 to what power is 125? Well, 5 to the third is 125, and because it's a 1/5, it's 5 to the -1. So I'm going to assume it's -3 is my answer, but let's write it out. The base raised to the y power, which is what we're looking for, equals 125. That's 1/5 is 5 to the -1. Power to a power, we multiply exponents. My expressions are equal, the bases are equal, therefore the exponents have to be equal. So this value is -3. Six to what power is, I'm sorry, the base is not 6. The base is 36. To what power is 6? Well, 36 is 6 squared. A power to a power, you multiply exponents. The expressions are equal, the bases are equal, therefore the exponents have to be equal. And the answer is, or the result value of this logarithm is 1/2. Why? Because 36 to the 1/2, or square root, is 6. Okay, I wrote out some logarithms here. On the left, we have a common log. If there is no base written, it's assumed to be base 10. That's called a common log. A common log. And I'm going to start with a 1, a 10, a 100, log of 1,000, and log of 1/10. If you'll think with me a moment, we're going to go right through these. 10 to what power is 1? 10 to what power is 1? 0. How about here? 10 to what power is 10? 10 to what power is 10? 1. There's no 10 written there, but log means base 10 if it doesn't say it. So 10 to what power is 100? 10 to what power is 1,000? 3. 10 to what power is 1/10? -1. So what do you think the log of, you might notice a pattern. What is the log of 10,000? 4. Now log base e is called a natural logarithm. So I'm going to put a 1 over e, 1 e squared, e to the third, and so on. The base is e. E to what power is 1? Well, e to the 0 is 1. E to what power is e? E to the 1 is e. Now this is going to sound silly, but just listen to me a minute. E to what power is e to the 2? E to what power is e to the 2? 2. E to what power is e to the 3? 3. E to what power is 1 over e? -1. Now, a lot of people will think in the upper level mathematics is they just learn tricks. Natural log and e eliminate each other, so this would be 4, right? Because e to the 4th is e to what power is e to the fourth would be 4. Let's do this one. Let's do a 1, a 1/2, a 2, a 4, and an 8. These are base 2. So 2 to what power is 1? Be 0. 2 to what power is 2? 2 to the first. 2 to what power is 4? 2 to what power is 8? 2 to what power is 1/2? Anyway, these are some of, just trying to get you to get a feel for some of the logarithms. Natural log is by far the most useful. Number 1, a log base 10 is called a common log. So number 1, you're just filling in common for common log. Number 3, rewrite it in exponential form. They give us log base 4 is 16. Log base 4 is 16 equals 2. Well, you do the base. Here's the way a lot of people, please watch this. I never got much out of this, but a lot of people do. They say use a fish hook. Watch. Like that. So you're going to say 4 to the second equals 16. I don't know if that helps. Okay, let's see if we can do this again. Take the fish hook. You're going to do 6 raised to the negative 2 equals 1 over 36. Number 7, you go in the other direction. You have it exponentially, you want to write it with a log, and the base stays the base. So I would put the 1/8 here and the negative 3 here. You can check it. Is 2 to the negative 3, does it equal 1/8? And yes, it does. So what did they do wrong? They have log base 2 of negative 3, so they don't have it written like this. Okay, how about 7, or number 9 here? You might want to think of it as 7 to what power equals 49. And it happens that it's 7 to the second is 49. So the answer is 2, because 7 to the 2 is 49. And number 11, you want 2 to what power equals 64? 2 to what power equals 64? 2 to the 5th is 32, so that'd be 2 to the 6th. And I think it would be 2 to the 6th is 64. On 13, you want 1/2 raised to what power equals 8? Well, 1/2 is 2 to the negative 1, and a power to a power, you multiply exponents. 8 could be 2 to the 3. So if negative y equals 3, y is going to equal negative 3. On 15, you're going to say 16 to what power equals your argument of 1/4. These are both powers of 4, so 16 is 4 to the 2. A power to a power you multiply. 1/4 could be called 4 to the negative 1. So your bases are equal, your exponents have to be equal to y equals negative 1. And your answer for this one would be negative 1/2. Now let's think logically about some of these, like the next one I'm about to point out here, please. Natural log of 6. The base, if it's not written, of natural log is base e. E is about a 3, 2.7. So 3 to what power equals 6? Well, I know it's going to be 1 point something, don't I? Because if it was 3 to the second, it would be 9. But they just want us to punch it in, so I punch it in and I get 1.7917. to 3 decimal places, 1.792. Excuse me, 23 is a common log. So I'm going to hit LOG of 6.213, and this is going to give me 0.7933. So again, these are just punching it into your calculator. In this group of problems, they want us to use the inverse functions to evaluate. Log base 5 of 5 is basically a 1. It eliminates each other, leaving you your result to be x. Log base, if there's no base, it's assumed to be base 10, a common log. 10 raised to log base 10 are inverse functions. They eliminate each other, and the result is 8. This one's a little different because it's not log base 3 of 3 yet. 81 could be called 3 to the 4th. So I have log base 3 of 3 raised to the power, you multiply 4x. Now I have a log base 3 of 3 to eliminate each other, giving me the result of 4x. 35 is similar. I need to make it into log base 2 of 2. 32 is 2 to the 5th. A power raised to a power means you multiply exponents. Log base 2 of 2 are inverse functions. They eliminate each other. And the result here would be 5x. Okay, that was inverse functions. Here we want to actually find the inverse function. Now I know the inverse of log base 8 of x would be y equals 8 to the x. That's going to be my answer. But let me see if I can actually derive it here. To find an inverse function, you switch x and y and solve for y. So that y becomes x, the x becomes y. Now I'm going to write it exponentially. 8 to the x equals y. 8 to the x equals y. So that's what you're supposed to do, I believe, is to rewrite it as its inverse. And if you know that logs and exponentials are inverse, you might even know 39. 37 gave me a log, it ended up an exponential. 39 gives me an exponential, it's going to end up a log with the same base. So that's going to be the answer for 39, but let's see if we can derive it. So I have 0.4. Again, you switch x and y and solve for y. You're not going to see this yet, so let's go ahead and write it out. X equals 0.4 to the y. To get rid of the base of 0.4, I'm going to do log of 0.4. Log of 0.4. So I get log of 0.4 of x equals, and you'll notice these eliminate because they're the same base and argument, equals y. So just like I thought, that is the result. Now, 41, if I switch x and y here, what's going to happen? This is going to be x, this will be a y. I want to solve this for y. And I haven't taught you all this yet, but maybe we can pick it up as we go a little bit because it's all going to be coming around in this chapter. To get rid of an e, you natural log it. So I have to do it to both sides. Natural log and e are inverse functions, so they eliminate each other, leaving me just the y plus 2. Now to solve for y, all I would have to do is subtract 2. And that would be the inverse for 41. Okay, the last group of problems I think wants us to graph it. I usually recommend you change it to exponential, which would be in this case 4 to the y equals x, 4 to the y equals x. You are very used to making an xy table and choosing x values. Now I'm going to suggest you choose y values. Let y be 0, 1, and negative 1. If y is 0, what's 4 to the 0? 1. If y is 1, what's 4 to the 1? 4. If y is negative 1, x would be 4 to the negative 1, or 1/4. So what's different here is you're not plugging in values for x, I'm plugging in values for y. And when I do this, I get 1/4 negative 1, which is down here, 1, 0, and 4, 1. And you'll notice that it looks like this. It does have a vertical asymptote at 0, but that would be the graph of log base 4. And we could label these points 0, 1, 4, 1, and so forth. How could I write 49 exponentially? Well, could I do 2 to the y equals the argument? So I think I could do 2 to the y equals x plus 3, right? So 2 to the y minus 3 would equal x. Again, let's make an xy table, but let's choose values for y. How about 0 and 1? Let's start with those. Does anybody know 2 to the 0? 2 to the 0 is 1. 1 minus 3 would make it negative 2 for x. How about if you put in a 1? What's 2 to the first 2 minus 3? Would that be negative 1? How about if you put in a 2? What's 2 to the 2? 4 minus 3 would give me a positive 1. So let's just graph these to start with. Negative 2, 0 is over here. Negative 1, 1 is about there. 1, 2 is up here. I notice that this shifts everything over. So is it going to look something like this at negative 3? It looks, hang on one second. I apologize. I thought something was wrong because it's x minus 3, not x plus 3. So it should be x minus 3. Then you would add 3, right? I apologize about that. I had it as minus. How about if y is 0? That'd be 2 to the 0, which is 1 plus 3 makes 4. I'm sorry, I wrote it wrong. If y is 0, what would x be? 4. What if y is 1? What would you get? 2 to the 1 is 2, plus 3 is 5. How about if I put in a negative 1? 2 to the negative 1 is 1/2. 1/2 plus 3 is 3.5. So what I have here is 3.5, which is about here, negative 1. 3.5, negative 1. 4, 0 is going to be here. And 5, 1, 2, 3, 4. I'm sorry, I have that backwards. 4, 0 is going to be here, and 5, 1 would be about here. I notice that what makes this 0 is 3. That's where the vertical asymptote is at 3. So it actually should look something like this. Again, if you have a graphing utility, you might be able to graph this on your calculator.